Hey guys, so today we're going to go over tables in Roblox Studio. Tables are probably I would argue, the single most important thing in Lua. I mean, obviously you can't do things with only tables, but it's very important to kind of know what's going on here to really use Lua to its full extent. Uh, Lua meaning the scripting language of Roblox. So to get started here, what is a table? A table is just a variable, which is a collection of other variables, really. The way you set a table is you have whatever the variable name you want. I say table1 here, and you set it to brackets. If you just set it to brackets like this, it will just be a blank table. There won't be anything in it. But this is how you would have to set things in the future for certain other things. I'll probably make other videos that show me setting a table to blank. If you ever see like meta table videos, you'll probably see sometimes they'll set. I think most of the time I think they actually set a blank table before they populate anything. But anyway, going back to this, the basics over here. So I already have a table created here. Table 1 is A, B, and C. So what these are the values of the table. So table 1 has the first value is A, the second value is B, and the third value is C. And just to kind of exemplify that, I have another table 1 here. I'm going to uncomment that now. Over here I have A, B, and C. I kind of mixed these up for a second there. I'll probably do that again in a sec. So these tables are actually identical, even though one of them has these keys or indices here. What happens up top here is the keys are just kind of assumed. So the first value is A, that means is 1. The second value is B, that means that's 2. The third value is C, that's 3. If you want to do what I had before essentially and have like 1, 3, 2, this will actually auto sort in this case. I'll explain what I mean in a second. But this will not be the same if you put like the C in the second slot. In up here, it assumes whichever slot it's in is the number that is associated with it. So this is how this should come out. And just to kind of show you what I mean, I'll comment this out again. So now we just have table 1. Down here I have a for loop. So let me actually show this over here. So a for loop is we're just going through the table and doing things with the values in the table, the indices and the values in the table. So for example, for index comma value in table 1. So table 1, the index are the numbers. It's these numbers down here. Over here, these numbers are assumed to be 1 for A, 2 for B, and 3 for C because it's the first, second, and third value. So what should this for loop do? Print index dot dot value. Dot dot is just a string library thing which it combines the two. So index dot dot value will theoretically print. Well, I didn't clear this before, so it prints right here. It will print 1A, 2B, and 3C. And just to show you that that's what is going to happen, I'll clear that just to get rid of the output here. Then I'll go back in here and unclear that. And I'll play. And then you see 1A, 2B, and 3C. Stop. All right. So that was with that table. What about with this table, where I said it's the same, but never trust me. I'm not trustworthy. So we're going to test the same thing. We see table 1 here, A, B, C, but now I actually specifically have the values here. Is it going to be the same 1A, 2B, 3C? I say yes. Let's try it. 1A, 2B, 3C. Beautiful. It's exactly what we were expecting. Next, let's do what I had before, where now I'm going to put the 3 up here. Keep in mind, if you want to set your tables up like this, you can't do this where you put C as the second one and expect it to know that that's the third letter of the alphabet. You would actually have to put the numbers here so that it knows what order it's in. So if I print this, it should give me the same thing. 1A, 2B, 3C, exactly as I was expecting. Beautiful. Is there any situation where you would want to put it out of order like that, where it's 1, 3, 2? Probably not, but you might have a situation where in the code you're doing something manually, and it ends up happening like that, which is not the biggest deal in the world, but you have to be very, very careful when you work with that because of the next thing we're about to talk about, which is what really is a table, and are there multiple kinds of tables? The answer to the second question, are there other kinds of tables, is yes. So there's 2 kinds of tables. The table we have been working on thus far, this table, table 1, is called an array. Arrays are sequential tables, which means, what I've been explaining thus far really, is that the indices or the keys on the left side of the equal sign over here are in order, are numbers and in order. So for example, table 1 up here will have A, B, and C. These are assumed, this is assumed to be an array, and it assumes that it is in order starting from the number 1. So 1, 2, 3, this is an array. Down here, it doesn't have to make the assumption, this just is an array. It goes 1, 2, 3, it's in sequential order. There's no gaps. Gaps would be if this was nil, then this is, I would no longer qualify this as an array. And we actually have examples down here. So this is an array. And what is the behavior of an array? We actually already saw it several times already. When we do this for loop, which this for loop, for index value, it cycles through the table in sequential order. And I'm not 100% sure on if this is actually how it does it, but I believe what it does is for index is equal to 1, comma, hashtag table 1 do. I believe this is what happens. What this is a regular for loop. It's not a pairs loop. This over here technically counts as a pairs loop, but Roblox, by default, you don't have to put pairs in there anymore. So over here, what this would do, essentially the same thing as this, is it loops through all the indices starting from 1 and incrementally increasing as it loops through until you get to the total size of table 1. So the total size of table 1 here is 3. 1, 2, 3. And we'll go over this again in a bit. But it'll loop through here saying, let's say if I want to do this same thing, it'll print the index, which it would be 1, and the value at that point, in which case it would be A. So if I really wanted to write this out, which I guess I could do that, print index table 1 index. This is essential. These are essentially the same exact thing. So if I do this, as you can see, A, B, C, A, B, C. So same thing printed twice. These are the same thing, and this works with arrays. And this is actually, I'm going to leave this up because when we get to the problem situations, I can explain kind of why it doesn't work anymore in those situations. Whoops. So we've got table 1, ABC. All right, so I said that this is an array kind of table. What is the other kind of table? There's only two. This is the other kind of table. This is a dictionary. A dictionary is a non-sequential table. So an array is a sequential table where you have the indices or the indices or keys or however you want to say it. These are in order, in numerical order, and there's no gaps between one or number or the other. But dictionaries don't have that kind of order. What that means is even though you as a human see ABC here, the computer doesn't recognize that ABC is in any kind of order. It just sees that, oh, it's a dictionary. All right, I can do whatever I want. And that is exemplified here. So this is the for loop for table 1. This is the for loop for table 2. So you see the only difference here is the table 1, table 2, which means if we loop through this, I mean, theoretically, just looking at this, since it's the same loop, table 1 resulted in 1A, 2B, 3C. Theoretically, table 2 should result in A1, B2, C3, right? Let's see if that's what happens. So here we go. Let me stop so we can make changes if I want. So we can see table 1. It said 1A, 2B, 3C. All right, now for table 2, which is the second part, it says A1. That's expected. That's cool. Then it jumps to C3 and then goes to B2. Why is it jumping around like that? It's because it's not sequential. It doesn't see it as going in order, so it just kind of randomly picks. And this behavior is why certain code you'll likely see in the future is the way it is when it comes to either changing dictionaries into arrays or the way dictionaries are looped through or something like that. There's a method to people's madness, and it's because arrays and dictionaries are not the same thing and can cause issues in the future. All right, so we get the difference between arrays and dictionaries. Now, why is it important to know those differences and basically accommodate for those differences? That's because of this table here. Let's start with table 3 here. Table 3 is, it kind of looks like an array because there's numbers here, but these aren't in sequential order. You can see there's 1 and then it skips 2 and goes right to 3. So what does that mean? That means that there's a bunch of things that are not going to work properly for this. So for starters, let's go with the length of the table. This hashtag over here, this is basically the default Lua code for length of the table, or length of the array specifically, because it really only works with arrays, and I'll show you here. So this hash table 1, this should be 3, right? So this is going to be 3. Hash table 2, now, I just told you it only works with arrays. So hash table 2, it's trying to find all of the sequential values, but there are no sequential values. Therefore, it's going to say 0. Now, hash table 3, this is where it gets fun. Table 3. There are sequential values here. There's exactly one of them. So what is going to be the result here? 1. When in reality you want the size of the table, it's going to give you 1. Let's test that. Play. What'd I tell you? So we have, let me stop this first. Okay, so we have the size of table 1 is 3. The size of table 2 is 0 because it is a dictionary. There are ways to get the length of the dictionary, but you have to create a specific function for it. I'll probably go over that in a later video. Table 3, however, is 1, even though we clearly see 2. So people generally think of this hash as like the length of the table, but it's really just the length of the sequentiality of the table, which is sometimes you can mess that up too. So what happens if we do something like this? Now, not only are we not sequential because we skip 2, we also skip another 42 up to 45. Then we skip another 400 something. Then we go backwards to 4, and then forwards again to 9. So there's the backwards and forwards really isn't the point here. It's not the problem here. The problem is the skips, the nils here, because it automatically tries to sort it, and you'll actually see that in a second. So what happens here? We already know 3 and 0, so I'm going to comment these out. But what happens when we try to get the length of table 3? 4? Table 3 is 4? How you figure that? That looks like 6 to me, buddy. So yeah, it thinks it's 4, and the reason it thinks it's 4 is, honestly, this is one of those points where I'm kind of lost as to why it thinks it's 4. I think it's because 1 exists, 3 exists, and 4 exists, and it kind of it's okay with skipping 2, because there's additional skips later on. But the long and short of it is, it should not be treated as an array, because the normal array functions just simply will not work on it. It can't truly get what is within the table. This is one of the problems with working with Lua, really, where you really have to be mindful of whether you're working with a dictionary or an array. And when you're not absolutely sure that you're working with an array, just assume you're working with a table, or you just assume you're working with a dictionary. Because it is very easy to know whether or not you're working with an array. Having things be in sequential order like this, it's very easy to find out. Now, table 3, what else? Just for fun, let's do a few other things. For index, comma value in table 3 do. So what happens here? Does the for loop treat this as an array or not? Whatever. I can do that again. Not the biggest deal in the world. Does the for loop treat this as an array or not? The answer is it tries to, but then it fails. So let me actually copy this part so we have a better idea. I'm going to print table 3. So let's do this again. We go back here. All right. So what happened here? We go 1A, fantastic. 3C, fantastic. 4R, that worked out. What happened next? 45D. What? And then 9F. Then 539. So look at what seems to have happened here. It seems, and I'll double check this by changing this to let's change it to 35 and see if something similar happens. So this looks like it tried to go in a weird kind of numeric order, but then like it completely confused itself around the 4 and 9 area. And yeah, and so it didn't actually sequence it properly. Let's find out what happens when we change this to 35. This it should be just do the same thing, right? Oh no, now 35 is at the bottom. So it really has no idea what to do with some of these numbers. That's basically what it is. And this is just to exemplify and show you that if you have holes like this in your table, do not treat it as an array. Never use the table functions. Table functions would be like insert, remove, I think you can still use concat, but there's certain things that you can technically use with both dictionaries and arrays, but most of those functions are you try to leave them to the to arrays and only arrays. So anywho, how do we get information from tables like this? Let's find out. We go to this table over here, or we go to this for loop over here. So I'm gonna first, let's go to table 1. I created 5 little things here, 1, 2, 3, 4, 5, A, B, C, D, E. And let's actually close this. So right now, table 3, or table 1 has 5 values, 1, 2, 3, 4, 5. Table 3 has 2 values, A and C, for 1 and 3. I know there's 5 values, so I'm just going to use a regular for loop, I equals 1 to 5. So it will loop through 1 and keep adding 1 until it gets to 5. I'm going through the table 3 and checking the iterations. So at first it'll do 1, then it'll do 2, and it's checking if that is nil. Then if it is nil, do something. An example of where this would be relevant is actually in the game I'm making, an inventory system. I have an inventory system where my backpack is a bunch of it's a dictionary, but it looks like an array because there's 72 values, like numerical values, but sometimes they will be nil. I have to be very mindful to treat that as not an array for most of the time. And that's what this is basically what I do, except in a much simpler form. I loop through numerically here, check to see if I is nil, if table 3 and this specific spot in table 3 is nil, and if it is, then I can add or move an item to that location, essentially. And in this case, I'm just going to print this part of the table is missing from table 3. So if I print this, it's just going to go through 1 through 5, and as we can see, it says so A is there, C is there, 2 is missing, and 2 is B, so B is missing from table 3, and then 4 and 5, which are up here, D is missing from table 3, and E is missing from table 3. So that's the gist of it. That's the basics of the basics of tables. I'll probably do more about tables because they're fascinating creatures, really. And it's really actually funny how some of those functions meant for arrays don't work very well with things that look like arrays. I'll make a little fun video about that later. That was a fun day when I figured that one out. Anyway, I hope this helped you guys, and I'll be making more videos soon. Bye.